Hi, welcome to an episode of Foxy Little Nuggets. I was preparing tonight's news stories and looking for the "and finally," the uplifting story I like to finish on. I've landed on something so extraordinary and so uplifting that I've got to do a separate story about it in and of itself. And trust me, you really want to listen to this. This is one of that very rare times when it truly is good news, brilliant news, fantastic news, potentially changing the lives of every single person on this planet for the better. And it starts very simply. It starts with a very small green frog. And the story I'm about to take you on, I think, is stunning. Now, when I heard it, I looked and there was various scientific papers and there was a couple of articles in papers, but the ones in the media, they sort of just, they're brief, they just cover things. So I've done a little bit of research on this and I've written a script and I'm going to take you through it. It shouldn't take more than about 5 minutes or so, but absolutely stick for the journey because at the end of it, you're going to feel a lot better, a lot more positive. And I'm just stunned that this hasn't made world news. And I'm not exaggerating. Let's go. I will just say that since we're talking about frogs, I've got a terrible pun, but you'll hear it at the end. I've called this the frog that beats cancer. And you heard that right. Because every so often, a scientific story appears that sounds less like medical research and more like the beginning of a fairy tale. And this is one princess that's kissed the right frog. A small Japanese tree frog is collected for study. Scientists examine the organizations living inside its intestines. Among dozens of ordinary-looking bacteria, they find one particular bacteria with an extraordinary ability. They isolate this bacteria, they grow it, multiply it, and then inject it into mice that have colorectal tumours. One dose, one small dose. And the tumour disappears. Not partially, not merely slowed down. In the experiment, 100%, every treated mouse, all of them, achieved what researchers thought was impossible. A complete response. Every single mouse not only survived the colorectal cancer, it beat it. And it didn't just beat it. On testing these mice for cancers after the event, there was no detectable tumorous matter in the mouse's body. The bacteriophage had eaten the tumour, and the mice were scurrying around, perfectly happy. When scientists later tried to establish the cancer again by re-injecting the cancerous tumour cells back into the mice, the animals resisted it. The tumour did not form. The treatment had not simply destroyed the tumour that was there, but it had taught the immune system how to recognise the enemy and kill a cancerous cell. Now, at this point, I want to say, fantastic, but, and it's like, Oprah Winfrey, it's a big but. It does not mean that we have discovered a universal cure for cancer. This has so far been demonstrated only in mice, only using a particular experimental model of colorectal cancer. And many treatments that work in mice go on to fail in humans. But this is immense because this is way beyond anything that's ever been seen before. Not just 20%, 50%, or 100% better. We are talking orders of magnitude better. The bacterium is called Euwengelia americana. It was isolated from the intestines of the Japanese tree frog, whose scientific name is Drophytes japonicus. And as I say, despite the warnings, this is an extraordinary and profoundly hopeful result, because the gut bacteria in question can be grown en masse, and in all other senses does not harm the frog. It does not harm the mice. It does not harm a doctor who injected it into himself. Now, researchers at the Japan Advanced Institute of Science and Technology, JAST as it's known, examined bacteria collected from Japanese tree frogs, Japanese fire-bellied newts, Japanese green grass lizards, etc. They isolated 45 different bacterial strains and screened them all for anti-cancer effects. 9 showed some activity, but E. americana stood far above the others. And so the scientists tested it in mice carrying these colorectal tumours. Like I say, a single intravenous dose, and it was 100% successful. Now, for comparison, the researchers also tested, because you do control groups, established treatments including liposomal doxorubicin, which is still experimental but is very, very effective. It's a form of chemotherapy, and an anti-PD-L1 immune checkpoint drug. In this particular mouse experiment, frog bacterium performed better than both of the others by a long margin. That alone would be remarkable. But what makes the discovery especially fascinating is the way the bacterium seems to work, because it does not rely on a single attack. It fights the tumour in 2 different ways simultaneously, in a way never observed before. So even if this doesn't necessarily end up directly leading to a human form, they've learnt something new, and it could change alterations on existing treatments that would become much, much more effective. First of all, though, the bacteria themselves travel through the bloodstream and gather inside the tumour. Solid tumours are not neat, sort of orderly, healthy pieces of meat or anything. They grow rapidly, the blood vessels are abnormal, they're leaky. Many regions inside them receive very little oxygen, and these particular bacteria like areas of low oxygen. It's what's called a facultative anaerobe. It means it actually thrives in low oxygen conditions. Normally, oxygen-starved environment makes tumours difficult to treat. Some drugs cannot penetrate them properly and can't get into the centres. Certain immune cells struggle to operate inside them because there's no oxygen. But Americana is there. Once inside the tumour, the bacteria multiply massively, dramatically, 3,000-fold within 24 hours. They did not spread indiscriminately throughout the body of the tumour. They concentrated in the low oxygen area right in the centre of the tumour, and then start damaging the cells and basically phaging, eating the cells. And in effect, the bacterium uses the tumour's own abnormal biology against it. The tumour attempts to build protective sanctuary, low in oxygen, shielded from the immune system, and supplied by defective blood vessels. But those same features create an absolutely lovely landing zone and gourmet meal for the bacteria. Then comes the second attack, because having bred so much in order to start eating the tumour from within, the body's own defence system recognises that there's a biological attack. And it warns and alerts the immune system. So then T cells, B cells and neutrophils all move into the area around the tumour, trying to get at these bacteria inside the tumour. And so these T cells start attacking the tumour in order to get in. And so with the eating from the inside out and then the attacking from the outside in, the tumour is literally blasted away like a character in a video game within hours. And it may also explain the most hopeful part of the experiment, and that is the apparent protection against the cancer returning, because all those T cells eating at the tumour then say, we recognise this as foreign, so any future tumour that comes or any future cancerous cell that comes in, the T cells are primed, recognise it, and kill them. Injecting live bacteria into the bloodstream would normally raise immediate concerns about severe infection, inflammation or damage to healthy organs. However, the immune system within the mice was fine. The safety findings were encouraging. The bacteria disappeared completely from the blood very, very quickly. Their measured half-life is about 1.2 hours. They were undetectable in the bloodstream after 24 hours. There's no bacterial colonization in any healthy organs, including the liver, the lungs, the spleen, the kidneys, the heart, the brain. There was a mild inflammatory response. In other words, I've got an infection. Body raises temperature like it normally does. And then the temperature goes back down and the mice are gone. The bacteria are gone. Following this, the mice were then observed for 60 days, during which the scientists found no evidence whatsoever of chronic toxicity. Again, those results apply to mice, not people. Humans may react differently, but it's definitely good news. Now, the next stages must include obviously further laboratory work, tests in additional animal models, higher up the chain as it were, manufacturing safety work, regulatory approval. And then, of course, you could take people who are late stage 4 cancer, it's usually the end stage ones, inject and see what happens. If this works, breast cancer, pancreatic cancer, testicular cancer in men, all big, big killers, could possibly become treatable. And imagine you've got a tumour and you go to the doctor and he goes, oh yes, I'll give you one of these, injection. And 24 hours later, you don't have a tumour. I mean, this is where they're going. It's elegant. It's fantastic. The natural world remains almost incomprehensibly complicated and wonderful. And it's another reason why we shouldn't be cutting down the rainforests. There could be a cure for everything in a rainforest. This one was found in the gut of a tree frog in Japan. Think what else is sitting in the Amazon. As I say, it's not a cure for human cancer today, but it's a quantum leap for tomorrow. It's exciting. Now, I promise you a terrible pun. I'm going to say this. As far as cancer is concerned, it's an amphibious assault vehicle. I told you it was bad, but it's hopeful. I hope that's brought hope to some people. Thank you very much. I'm stunned.